Okay, so for 9.4, we're moving on to volume of our prisms and cylinders today. So we're going to state the volume postulates. We're going to talk about the volume and apply the volume addition postulate and Cavaliere's principle. And we're going to apply formulas for volumes of prisms and cylinders. All right, so the first page is all just like information overload. We're front loading all the things. So first of all, a cubic unit we're familiar with, we've used a lot, a cube whose edges measure 1 unit. So it can be a centimeter cubed, which I've shown here for you, or it can be a yard cubed, but every side is cubed. Okay, it can be a cubic unit even if no unit is given. Volume then is the number of cubic units needed to completely fill a solid's interior. So the inside of it. So like if you would order dirt or cement, you would have to order it in cubic units. Okay, if when you order a dumpster when you get older, like maybe you want a dumpster at your house instead of just a trash can, if you live out in the country or something, you have to choose the size according to its cubic units. Okay, that's how they give it to you, because it's how much fills the dumpster. Okay, how much fills the dump truck, how much fills any of those things.
Is that why they'll like say like 4 by 5 by 8?
Mm-hmm. So if you use so 4 by 5 by 8, 4 times 5 would be 20, times 8 would be 160. So that would be 160 cubic units. They give you the dimensions, and then sometimes they'll give you the other.
What's it's length, width, then height, correct?
Mm-hmm. Mm-hmm. Okay, so some of our postulates today. The volume postulate. Every solid has a volume given by a unique positive real number. Okay, volume of a cube postulate. The volume of a cube is the length of one edge cubed. So we could say it's equal to V equals E cubed. E stands for edge. The volume addition postulate. Okay, if the interiors of two solids do not intersect, then the volume of their union is the sum of their volumes.
I have a question.
Mm-hmm.
Will we ever go into theoretical math?
No, not so much. Like we'll do imaginary in algebra 2, but we won't really go into like theory of math.
Because I was gonna say, like, can't you actually have a volume with negative? Because wouldn't that just be a black hole?
Yeah, that would be not what we're doing.
Okay, but like, I didn't know if we ever do that.
We do not. But yeah, like in theory, that would be a black hole. Okay, so volume addition is we just add them. It's like the same as when we had the area, right? We can separate it into two shapes that we can find the area of, or the volume of in this case, and then we add them together. And then congruent solids postulate. Congruent solids have the same volume. It's like, well, duh. Why is this even a postulate, right? Like, they're the exact same. So how many cubic units are required to build the illustrated right rectangular prism? So if we look at it as like a layer system, okay, each layer contains 4 cubes this way and 3 cubes this way. So how many does it take for this layer?
Just that layer?
Just that layer. 12. Okay. So then how many cubes is it going to take to make the next layer?
12. 12 for each.
12. It's going to be 12 for each layers. How many layers are there?
6.
It's the layers depends on its height. So then what's 12 times 6? 72. So how many cubes are needed to make this? 72. So it's 72 cubic units. Okay. So that's all it is. Like volume is a layered system. Okay. And so that might help you think of how you can figure out the volume. And it doesn't matter, honestly, if you do the layer that way or if you do the layer, like if you want to look at the top, like you can count and verify that it's 12 per layer and then count the layers. You could look at the front face as well and say, well, there's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So that's 24. And then there's how many layers of 24? 1, 2, 3 layers of 20. If you stood them up like books, right? Instead, if you looked at the layers. However, does that make sense, what I just said? Do what?
I was gonna ask a question, but we'll get there.
Okay, I was going to say, but because, again, it doesn't have to be layers like this if you would want to make the layers like, okay, this is my first layer. It's a little harder, right? This is your first layer, like your first book, and there's 24 in there. And in the next layer, there's also 24. And in the last layer, there's 24. 24 times 3 is still 72 units cubed. That might be a little bit harder to look at and see visually. All right, then Cavalieri. It is. Right. Okay. So Cavalieri's principle says for any two solids with the same height, if all the planes are parallel to a fixed plane, they form sections having equal areas, then the solids have the same volume. Okay, so we're comparing the right to the oblique here, whether it's straight up and down or it's slanted. As long as it's base, right, and everything up from there are parallel, it does not matter. Okay, then they still have the same volume, which is why we have height, but we also, why this one has the height extended out. It's not the slant height, like when we did the cones, remember? In a cone, we had the height. So what was the point, the height from the middle to the top of the peak? The slant height was the angled side, okay? Yes, okay. So we don't care, like when it's talking, we don't care about the slant height. We care about the actual height of the shape when we're talking about this, okay? So sometimes it's going to be drawn outside. So if it is a right cylinder or a right prism, it's going straight up and down, it's at right angle to the base, okay? Then we use that height. If it's not, we have to find where the height is given that's perpendicular to the base. That's the height we're going to use. But this principle implies that the same formula can be used for both right and oblique prisms. It doesn't matter as long as we know the height, the distance from the top, okay, or the base, the top base, all the way to perpendicular to the bottom base is the height. It's always perpendicular. All right, questions about that? All right, then the theorems that we have today. A cross-section of a prism that is parallel to the bases of the prism is congruent to the bases. Okay, well that's what we're talking about, right? The cross-section, this shape is congruent to the base because they're prisms. Like on the previous one where we cut the layers and layers and layers, they're all congruent. We use that theorem to help us. It was just something we innately knew. All right, then we have the volume of a rectangular prism. Okay, is the product of its length, width, and height, so volume equals L times W times H. Now that is not slant height L, right? You do have to notice the difference. The volume of a prism, any prism, is volume equals the area that's height, sorry, the product of its height and the area of its base. Again, to find the area of the base, it's going to depend if it's a pentagon, a hexagon, an octagon, whatever. The volume of a cylinder is the exact same. It's still the volume equals the base times the height. If it's a circular cylinder, our base, we find the area of the circle, which is pi times the radius squared.
What is a cylinder that's not circular?
Some of them can be, like they can be an oval cylinder. I know, but there are other cylinders that are smooth, but they would be oval in shape. Mm-hmm. Or if like, you know, like the heart-shaped, if it was like a heart-shaped one, okay, it's got the smooth lines and no sides.
So it's a cylinder is basically a prism without sides.
Correct.
Okay.
Mm-hmm.
So any shape that. Okay. So would a cylinder be a square but it has a curved side? Would that be considered a cylinder? Like your base and your top would be like it's like a square, right? But one of its sides curves outwards.
Like this?
Yeah.
Okay, so we would actually define the area of that, we would cut it into the rectangle, and then we'd find the area of half of a circle, because that would be a semicircle.
Like cylinder-wise, would that be considered a cylinder, or would that be considered a prism? Or would you just cut it still in half to make a
A semi-cylinder and a prism is what, yeah. That's a good call. I don't know how it would be classified technically, but to find the volume of it, yes, you would use that principle that we talked about, the volume addition postulate, and you would cut it into the two parts you could find and then add them back together.
And then how'd you find the volume for what are those pyramids that we were talking about yesterday?
The truncated ones?
Yeah. How'd you find the volume for a truncated pyramid?
Like I said, you'd have to find the volume of the little pyramid and then the big pyramid and subtract them. Yeah.
But how can you find, like, how would you be able to find the little pyramid?
They would have to give you enough information. They'd have to give you like the slant height and the height to do that, to find it. Yeah, good question. Okay, so we're gonna put it into practice. Okay, front loaded all the information that you need, which is really the formulas and kind of a basic understanding. So let's find the volume of a regular prism. What's the formula for that? That's for a rectangular. This is a regular. Okay, it's the area of the base times the height of the prism. Okay, well, we know the height. What is the height here?
14 square root.
Okay, so that's our height. How do we find the area of the base, that capital B?
I know.
8
times 6.
No. That's the perimeter.
8 times 6 is the perimeter, but what's the formula for the area of this shape?
1/2 apothem.
Okay, so area of the base is 1/2 the apothem times the perimeter. Okay, because any regular n-gon, no matter what shape, that's how we find the area of it. Remember, the base, it's the area of the base. So we're going back to those area formulas on your reference sheet. Okay, but we did need to know the perimeter. Okay, so P was 8 times 6 or 48. That's going to be a helpful number that we need. So how do we find the apothem? They've got it drawn, but they don't have it labeled. Mm-hmm. This was on your quiz, and we did it in our notes last week.
Huh.
Okay, so remember, you can divide your hexagon into 6 equal triangles. Your apothem is drawn there. It's a right angle to the base, or to the edge.
Use that triangle, which makes a right triangle.
Does make a right triangle. So you said we use half of it. So this is 4. What's to this side?
You don't know.
We do, because they're equilateral. So if this side is 8 and it's an equilateral triangle, what's this side?
That'd also be 8.
It is also 8. So like if I took this, okay, this way, this is 8, my drawing is not very good, this is 4, and there's my apothem. How am I going to find my apothem?
This be the x 2x.
Okay, if you know that that's a 30, 60, 90 triangle.
But we don't know that.
Do you know if it is or not? It's a right angle, but every right angle is not a 30, 60, 90 triangle. No, you can know it, but is it?
You do the Pythagorean theorem instead, just because it's a safer option.
You can do the Pythagorean theorem because it's safe, like it's right triangle, Pythagorean theorem. However, you can also know the other way. So we would say a squared, what?
4 squared.
Plus 4 squared, because those are the two legs, has to equal 8 squared. So then you're going to have a squared plus 16 equals 64. What did you do next?
Subtract.
Good, subtract 16. A squared equals 48. What do we do next?
You do the square root of that, which is 6.93.
Okay, can you get me not a decimal? Because this is one that's nice to not have a decimal. I'll show you why.
7.
Nope, like give me the exact with a radical in it.
What do you mean?
4 times the square root of 3 is the answer here. Right, because your calculator gave you a decimal.
My number's gonna vary.
It will vary.
My answer.
Because it actually comes out to be an exact number.
Mine doesn't come out exact. Mine came out to.
Right. And so,
33.04566.
okay, so we'll look at your the calculator too and see if I can show you how to get it back in radical. But so when you have the radical in it, like the square root, it gives the exact answer. And I'm going to show you why it's helpful in this case. Lucas, to go back and answer your question about this one. It's a hexagon. A hexagon has 6 angles, right? So 360 divided by 6 equals 60 degrees, right? Okay, so if I cut this into 6 equivalent angles, right? That's terrible. Okay.
60.
What was it?
Said they're all 60.
The central angles are.
This is a 60, and so then if I bisect this one, it becomes a 30, and this one is a 90, so it is a 30, 60, 90. So you can prove, anytime it's a hexagon, it is always a 30, 60, 90. It does not work with a pentagon, does not work with an octagon. It only works that one, like x, 2x, x, or the square root of x, or the square root of 3 times x, or x times the square root of 3. That only works when it's a hexagon, but yes.
And then a square-gon would be a 45, 45, 90.
No.
Yes. Square-gon would be.
I know, my board is
Oh, now you
apparently seen its last days or something, I don't know. Okay. All right, so now we have the apothem and we have the perimeter up here. So now we can find our base finally. So 1/2 of 4 times the square root of 3 times 48. Kind of messed up. So it is. So what's 1/2 of 48? So we're going to have 24 times 4 times the square root of 3. What's 24 times 4?
96.
96. Okay, so then this is just 96 times the square root of 3. Okay, is our base.
Yeah, that sounds pretty good. Yeah,
Okay.
166.32.
Okay, but I want you to understand, like, radicals are like pi. You can leave them in there. And I'm going to show you again why. Especially in this one because we have a radical in our height. So our volume, I'm going to bring this down here, and our volume is going to equal our base, which is 96 times the square root of 3, times our height, which is what? 14 times the square root of 3. All right. I want to show you something. This is the same thing as saying, well, this is 96 times 14 times the square root of 3 times the square root of 3, which is what? No.
Which is 3.
Which is 3. So it gives you a very nice whole number if you keep it in the radical form. Again, if like you can see this and be like, oh, times the square root of 3. Oh, yeah, I'm going to have that here. I'm going to leave it. I'm not going to make it a decimal.
12. Okay. 96.
What?
Yeah.
For the answer?
96 times 14 times.
I was like, no.
K.
It'd be like 4K and something.
Yeah, it's 4032, which I got 4033.
Oh, okay. Well, you said K. 40. Okay, so our volume is 4,032 what?
Units cubed.
Okay, centimeters cubed.
That's what I said.
Because volume is cubed. It's cubic. Always. All right. I want you to know that was the hardest problem of the day. What?
Can I use the restroom?
Can you hang tight for just a minute? Let's do one of the circles.
I have to order my lunch while we wait for the 5 minutes.
Okay. All right, so let's try the next one. Again, this was the hardest one, I promise. All right.
Is my answer correct or no?
I would take it.
Okay.
Yeah, just looking at it, you did it differently, but I would take it. All right, so how many cubic inches of sand are needed to fill the cylinder? What's the formula for the volume of a cylinder?
I want to do it this.
V equals pi r squared h.
Okay, so it is BH still. Okay, but then you have to think, okay, what's the area of the base? Well, the base is a circle, so what's the area of a circle?
Would it be
No, it's pi times the radius squared. Right? If you go back to the area of a circle, pi times the radius squared. All right. So that means our base is going to equal pi times, what's our radius? 5 squared. So b equals 25 pi.
What? Oh, I thought you said V equals. I'm like, no.
No, b. b equals 25 pi.
So did you already have the height?
We already have the height. What's my height?
Well,
12. Yeah, so volume is just going to be 25 times 12.
well, it's pi. 25 pi.
Oh, sorry. 25 pi. Good call. Thank you. So v equals, and you can leave pi in your answer. 300 pi.
It's a lot of pies.
It is a lot of pi. I like pi, so I'm good with it. Inches cubed. Or if you give me the decimal, what'd you get, Caden? I assumed you did the decimal. Oh, okay.
No.
It's true.
Ready?
Yep.
942.477796.
I'll take it. 9.42.5 or 9 point. Again, it's an approximation, so you could say 9.42.
Not 9.4.
942. Sorry. If it's an approximation, you could round to the nearest whole number. That'd be okay. Example 3, we're just going to work it backwards.
We don't have
Do you guys have this copied down? Okay. You're good. So number 3, we're working it backwards. To what height would 22,000 cubic feet of corn fill a silo with a diameter of 20 feet? So you know your volume is what?
pi r squared.
Okay, we can say pi r squared times the height this time. Lucas, what were you going to say? What's the value of our? So then let's look at these. What's the 22,000 cubic feet?
Would that be our height?
No.
Nope, because it's cubic feet. It says what is to what height? Height is our question mark here.
That would be our V.
That would be our V. Yep. So this is our volume. Okay, so we're going to say 22,000 equals pi. What's my radius?
Would that be the 20?
It's going to give us our radius.
Do you want us to divide by the pi?
Well, our radius is not 20. Our diameter is 20. So what's our radius? Diameter, radius.
He said.
10, right? Okay.
The diameter is 2 times more than the radius.
Okay. So this is pi times 10 squared times h, because we don't know it.
So, would you divide the pi or would you leave the pi with the h?
Nope, you divide the pi. You have to get h by itself. But again, you can leave pi in your answer. So this is 22,000 equals 100 pi times h.
So would you divide the 100?
You could divide by 100.
This equals
I think Coach brought his son today.
2200. Right.
So if anybody complains, it's going to be very sad.
You're right, because he had 2 zeros.
Okay, so that equals 220 equals pi times the height.
Then D divide by pi.
We divide by pi.
And approximately 70 equals h.
And so you could leave it as 220 divided by pi equals h, or it's approximately what?
70 equals h. 70.
No, not 70.
Yes.
No.
Yes.
Well, okay, because I was 69.1.
No, I got 70.02817496.
Okay, well, I got like.
So it would be 70.
Okay.
Look.
Oh, I put his calculator so nobody can see these are wrong. Automatically.
Let's see again.
Zero.
Interesting.
We had to throw him to the fire.
No, yeah, it is 20. Where did I get 691 or 69?
No, we have to throw her in the fire.
Oh, we have to throw her in the fire.
Yeah.
So she got it wrong instead.
Yes, correct. All right. Well, have a great day and a great weekend.
Thank you.
You too.
Thank you.